Bioelectronics at the heart is an interface between electrical engineering and biological systems. But in order to make the connection between two very different disciplines, it requires chemistry, physics, and more importantly, materials science. What we're trying to do is essentially create a bioelectronic Swiss Army knife, create biological electronic interface materials that can do all sorts of different signaling and detection. Our primary goal is to listen in on the conversations of our body. Then long term, what we'd like to be able to do is use our electronic devices to influence that biological conversation.
We don't have a way of getting at the immune response. We don't have a way of getting at molecules without drawing blood. And so the goal here is to be able to measure molecules of the stress response, of the immune response, of whatever aspect of health you can think of in a non-invasive, wearable way on the surface of the skin.
One of the limitations with the way that it is done today is that we're still using these archaic materials. We're still using silicon, the same material that's in a solar panel. This material is very flat, but yet our body is three-dimensional. We want our materials, our electronic materials, to be soft, to be flexible, compatible with our cells, our tissues, and our organs. We also want them to be able to be highly sensitive. The most challenging thing is that we really don't know much about these new flexible molecular electronic materials. Right? We want to use molecules to detect molecules in very minute concentrations. And we want to do this on a very small scale, down to say the size of a nerve. When I came in, he said he was looking at his substrate in order to... We're trying to develop new characterization techniques to provide us with a set of information that right now we don't have access to.
Which is a way of tracking in real time at every moment of the day and night how all your systems, your physiological systems, your stress response, your immune system, how they are all reacting to the various environmental challenges and stressors that we experience.
Not only can new materials help us monitor and improve our own health, but they can also help us improve the health of the planet. These new electronic materials have applications to renewable energy, clean water, and monitoring contaminants in our food supply.
There's going to be huge impact from devices like this. It's going to change the face of medicine.